Thank you, Julissa. First, let me introduce myself. My name is Marlon. Well, Marlon Peña. I'm from Lima, Peru. I'm software engineer. I've been working as this profession for around 13 years, and well, mostly of my experience have been designing systems and doing programming tasks. But I'm open to any kind of topic that involves technology. So, without further ado, let me share the presentation for this occasion. Just one second here. Mhm. And there you go. Okay. Okay. So, have you heard of this thing called quantum computing? Maybe you have heard some latest news about this topic, maybe events coming from Google or IBM. So, in this occasion, I want to try to give some insight about this topic that might sound scary or intriguing. So we don't have much time. Let's go straight into how a quantum computer looks like. And there you go. This is how quantum computer looks like, but but not really. So this is only one of its parts. This is only one of its components, and yet this golden chandelier like thing is to be believed to be a quantum computer. Um, to me, it looks like something straight out of a science fiction movie. And this makes me wonder: is this quantum computing actually a thing, or it's just science fiction? This question has brought some controversies in the science world and in society. And I'm going to show you two roads for to answer this question. So let's explore this road. The base that underpins quantum computing is called quantum mechanics. This theory, maybe you have heard of the famous cat whose owner, a scientist called um, Erwin Schrödinger, made experiment with this cat, a box, some radioactive element, a hammer, and a bottle of poison. Well, this theory is the foundation for quantum computing. So everything that holds true for this theory, it is true also for quantum computing. So quantum mechanics, it is a long-standing field. All the concepts, studies, experimentation have their roots in the year 1900. A long road for this field that had its bigger expansion time from the 1900 to the year 1930, where figures like Max Planck, Albert Einstein, Niels Bohr, and some other scientists found out breakthrough discoveries. And thanks to these discoveries, thanks to this theory, a vast number of objects were built, which are the basis for electronic devices. Objects like transistors, resistors, integrated circuits that make up the electronic computers that we see and use nowadays. So these little electronic components replace the big electric components that were used to build electromechanical computers. Um, these big monstrous mainframes, like you can see, they were really big, and is these electronic components, such as relays and vacuum tubes, which are very large, enable these quantum mechanics, enable that components become smaller, and we now have computers at home. So quantum mechanics is the base for all these electronic devices we see and use every day. And yes, yet electronic computers, what about quantum computers? But let's see what quantum computers struggles nowadays. So electronic computers are amazing, yes, but they aren't a solution for every kind of problem humanity tried to overcome. One area where electronic falls on its face is simulation and modeling. Simulation and modeling are long processing tasks which require a great amount of time to produce results. I'm not talking about just days or even months, but I'm talking about years and decades. High processing electronic computers take years to only, for instance, discover a new prime number. These are the kind of problems that electronic computers are facing nowadays. So, okay, scientists around the world said about 4 decades ago, hey, this quantum mechanics theory has worked so far to make the electronic computers. But okay, these electronic computers have seemingly reached their limit. There must be a way to use quantum mechanics to build a new kind of computer. And after years of researching, a well-known scientist posited we should use this theory and apply it to make a new way on how machines do computational tasks. This postulate was trying to lay out the foundations for what will become quantum computing. So a new field emerged, but how would it be possible to use quantum mechanics for this computational purpose? So to recap a bit, in electronic computers, we have the bit. This is the minimum unit of information, which can have two values, 0 and 1. But there's no intermediate value, like zero point 0.5 or zero point 0.7. In electronic computers realm, there are no such values. However, in quantum computing, the minimum unit of the information is the qubit. And as you can see, here is represented as a sphere. And it is represented that way because a qubit can hold multiple values at the same time. Like the Schrodinger's cat, whether it can be alive or dead, the qubit can have any value between 0 and 1 or multiple values at the same time. How is this even possible? How could a cat be alive or dead at the same time? Well, normal cats can, but in the subatomic level, that's how quantum mechanical works. In this level, uh, particles like photons, electrons, among others, exist. And classical physics does not apply here, but quantum physics. And there's lots out there. There's lots of material about what the main principles are for a photon and other elemental particles. Principles like superposition, entanglement, and others. But I don't want to go into these details. Just see the overall picture, and the qubits in electronic computers have inside these photons that have all these properties. And right now, the main challenges for quantum computer are to develop components and create the required state for these qubits to be in a coherent state long time enough to make possible the computational tasks. And this amount of time isn't necessary hours, just fraction of minutes. What Google and IBM and other companies involved in quantum computing are doing recently is just developing some quantum chips and that allows the qubits to be in a coherent state for just a few minutes. This is a race, and these companies are not the only racers. Entire countries like China are trying to win this race and lead the quantum computing supremacy. And last but not least, circling back to the original question, is quantum computing a real thing or is it just science fiction? There are people out there, different kinds of people, scientists like the man on the slide, Sir Roger Penrose, and engineers claiming that quantum mechanics is incomplete or wrong. Others saying that this is just a scam seeking for funds and that this quantum mechanics is just theory, but it is not practical. So I want to finish off by calling to action. We are engineers, we do practical stuff, but I want to encourage you to embrace science and the opportunities that come with all these unsolved challenges. Wake up your inner young and wake their curiosity, that curiosity we all had when we were children. Remember, together we can reshape the future of computing. And that's all. Thank you very much.
That's great. So maybe a question, if nobody has one. What's one practical application of this topic that maybe excites you?
Yeah, so practical applications now are this discovering from new drugs that will attack mainly, um, for instance, diseases like uh, cancer or these difficult diseases. So, by doing simulations, and many times they can find different strategies, different ways to fight off these diseases.
That's great. So we have